Okay, boss. Today we're going to start with BW on HANA or BW powered by HANA, boss. Means whenever we install BW, it must be installed with some database as the backend. So till now we've been installing. See, whenever you install BW, what you do is you install kernel, you install database first, then you install the kernel and the ABAP stack on top of it. Yeah. Till now we've been installing BW with Oracle as a backend or SQL Server or whatever it is, DB2, whatever it is, right? Now from BW 7.3 SP5, we have the flexibility of installing BW on top of HANA bus, where we're going to leverage HANA as DB, HANA as the database here. So once we have this BW on HANA or BW powered by HANA, we have some new concepts come out, some existing concepts change, and some concepts are no more available. So we want to look at the delta part of it. So what are the new concepts? What is come in BW on HANA? What are the concepts which has been gone out, or what has been concepts which has been enhanced? Okay. So as part of this, we're going to touch on HANA optimized info cubes, HANA optimized DSO, which is no more available now. We'll see how do we reconvert back, and how do we consume these HANA models in BW. Let's say if you have analytical view, calculation view, or attribute view, how do I consume that in the BW layer? About transient provider or virtual providers, and then importing BW objects into HANA. Let's say on top of HANA, we have BW. Let's say you have BW info providers. How do I import them into HANA database as models? Then we'll look into ODP, operational data provisioning with ECC. SLT, how do we configure SLT towards BW? Then advanced DSO, OpenODSV, composite provider. So this will be the new set of providers now with advanced DSO and OpenODSV and composite provider. Then how do we implement BW transformations with? How do we push down the BW transformations deep into HANA database by using stored procedures, which is as part of ABAP managed database procedures. Then since HANA would be a costly database, how do we reduce the size of the database and store it more cost effectively by using NLS, nearline storage? Then how do we push down the integrated planning functions through planning kit? Then we're going to touch on SAP HANA analysis process, same almost like APD, but with involvement of push down mechanism to HANA, we'll have it as HANA analysis process. Then LSA++ as architectural model. Then we look at how do we migrate the existing, let's say you got your BW running on SQL Server, how do we migrate it to HANA? That's what we're going to touch on this BW powered by HANA bus. Okay. So if you know about the cube already, now we're going to touch on HANA optimized info cubes. Now let's recap about the normal cube, what we already have. If you remember the cube, you have F table and E table previously, and this fact table was connected to the dimension tables, and the dimension tables was connected to SID tables, and SID tables were connected to master data objects. So this was the old schema, right? So we had two fact tables. One is F and E table. Unable to hear me? Can't hear me? Now, can you hear me? Okay. So now it's fine, right? Okay. Okay, boss. So I'm just trying to recap the about the info cube design in the previous normal BW cube, where we'll have F table and E table, right? Two fact tables, and fact table getting connected to your dimension tables, and the dimension tables get connected to your SI tables, and SI tables gets connected to your master data objects. This was the old schema. Now with the one, when you have your BW system, BW application sitting on top of HANA, and when you create a cube, the design is changed here. We call this as HANA optimized schema or HANA optimized cube. In case of HANA optimized cube, you're going to have only one fact table, which will be F, no more E table. You'll have single F table, and this F table will be connected to SID tables, no more dimension tables, except one dimension bus. You'll have only one dimension table still existing, which will be data packet dimension. Rest all no more dimensions. Straight away, your F table gets connected to SID tables, and from SID tables it will be master data bus. So your fact table is going to hold SIDs, no more SID generation bus. You will have single fact table, which will be F table, and F table will be connected to SID tables, and from there it will be connected to your master data objects. And it does leverages only single dimension table, which will be a data packet dimension bus. Only one dimension table is leveraged even now. Okay. So then how does this is leveraged here? So F table straight away. So F table is going to have the SIDs here, and which where from SIDs it gets connected to SID table directly, and from there to master data objects. Okay. Let's see in more detail. Let's. This is my BW 7.4 SP11. Okay. If you look at this system, sorry, it is SP8. Okay. Let's see first. Don't get confused. Don't get emotional. Once. See, now this is my BW system with 7.4. It says SP11. Okay. This is my BW system, and the backend database is HDB, which says HANA bus. Now, when you say HDB, okay, and it says HANA database is a backend, and what is the name of the database? SP9, and the server is SP Cubex, SAP Cubex. Now, this is what it is. So, this HANA database, what I've been showing you, it's actually backend of my BW system. Look at this. SP9 SAP Cubex. This is actually backend for my BW system. Not audible again. Why? Now okay again. In between there is a break in the voice. Okay. Now it's fine. Okay. Let me know when it. Yeah. If you look at the system, so for me the backend is HDB HANA database, and the system ID is SP9, instance is 01, and this is my server, and there's something called owner. I'll tell you what it is. Now, so this is my system backend database SP9, SP Cubex, and 01, and now it says something called owner bus. Owner is nothing but you'll have this. See, owner is nothing but SAP ABAP 1. So you'll have a user with ABAP 1. If you go to security, users, the SAP ABAP 1 is a user in HANA. So this is a user which is used for connection. See, when your BW application is sitting on top of HANA, when BW application is sitting on top of HANA, it means there is some database connectivity between BW and HANA. So for this connectivity, there should be some database user be used. So that is what SAP ABAP 1 is the user which is used for the database connectivity between BW and HANA. And as I already told you, every time there is a user created in HANA, it will have a schema with the same name. Yeah. So I should find a schema with the same name, right? SAP ABAP 1. So I have a schema here. Okay, good. So every time you create a user in HANA, it will have a schema. So this is the owner. So owner will have whatever the name you see as owner, you will have a schema with the same name. You'll also have a user with that. Okay. And this is user which is used for database connectivity. I can show you that. When you go to this DB cockpit, so DBA cockpit, okay. When you go to this DBA cockpit, you see this connections available. It says there is one connection to the database. So here the user which is used, DB user is SAP ABAP1 is user which is used for the database connectivity between BW application and the backend HANA database. You will have a connectivity. That is what, and this is the user which is used. Okay. And with the same user, you will also have a schema bus. The entire data dictionary of your BW application which is running on your HANA database, you can find them in this schema. Means whatever the table you say, for example, I go to SC11 data dictionary, I find some table here, say for /BAC/F something. Well, let's say I get to see some fact table. This is some fact table. I get to see the table here, as well as I should be able to see the same data dictionary object in this schema. If I go to my tables, if I say filter in the same schema, I should be able to see my table also. I see this table, look at this. I can see open definition. Same table is shown here, and I can also see the content also. Yeah. So what you should understand this now. So the logic is, so when BW is sitting on top of HANA, you would have, we call this BW schema bus. All the BW relevant objects would be automatically sitting into this schema bus. Okay. Fine. Now let's create a cube. Then let me create info area. So I've set that as favorite, so I see this info. So now I'm going to create a cube. So create info cube. It copy. Now it says standard cube, and which is what it says HANA optimized cube. Okay. Secret. So it is, since I've created a copy, it automatically takes in the sales org and there are lots of stuff. Lot of objects are already taken. Sales executive, norm. See, now what is maximum number of dimensions we could create in a cube? 16, right? Now in HANA optimized cube, I'm saying there's no more dimensions physically exist, right? Yeah. Even though there are no more physically dimensions exist, but still the limitations of 16 dimensions what we create here is still limited. You're just treating them as normal folders, okay? Normal folders. But the data packet dimension will still exist, but others will not exist with request ID. All this it will have still be there, and others will not. Others are just like a folders. And still you're limited to create only 13 and 3 fixed, and then 13 user defined dimensions. And I've just got some key figures. Okay, and then you can see some settings, which says only when the checkbox is enabled. It means, so don't worry about this checkbox now. I'm not doing it. This is a normal. What it says, cube type is standard, which is HANA optimized cube. Don't worry on this checkbox. Just activate. Now it's creating cube. So cube is cube Q1, okay. The cube has been activated. Now when the cube has been activated, if you once the cube is activated, I should see it should create some tables, right? I can see it from here. Display, extras menu. I can see. Sorry, XDB performance maintenance. Okay, I can just take this cube. So if I just say cube name star and then cube, yeah. See, you just get to see only F, which is when you say slash base slash F, what is this? It's a fact table. And when you see D and ending with P, what is this? What is this bus? You see a slash base slash D, which is dimension and ends with P. What dimension is this? Yeah, what dimension? It's a data packet dimension. As I told you, you'll only have single fact table which will be F, and it does create only one dimension table bus. So let's see fact table, what does it have? So it has got one is key, which is key for data packet dimension, which is basically connecting the dimension table. But for rest all characteristics, you get to see SIDs here, SID columns, and you still see the key figures. So SID columns and key figures. Only in case of data packet dimension, you get to see the data packet key, dimension keys. Okay. That's your fact table, and dimension table data bits all. So I can see it from here. And now the question is, when I create my HANA optimized cube in the BW system, should it create the corresponding table? You get to see those corresponding tables in the underlying HANA database also. And it does show those tables in which schema bus? In BW schema. Yeah. See, when I go to this SAP ABAP schema, I get to see two tables. One is slash BAC slash F cube Q1, which is fact table, and this is your data packet dimension. If you open the fact table, definition, you get to see the key for data packet dimension, and these all are SID columns connecting to SID tables, and these are your key figures. And what kind of table does it create in the backend bus? Look at this here. What kind of table does it create? What kind of table was? It's a fact table, yeah. Fact table is a column store table. It creates a column store table automatically. Okay, good. See, even though there are no dimension tables physically existing except the data packet dimension, while creating cube, still you're restricted with 16 dimensions max, 3 fixed and 13 what you can create. And even though the dimension table is not physically existing, still the limitation of 248 characteristics per dimension still holds good. Even when you create it, you just treat them as normal folder, but in the background it does not create any dimension table bus. Okay. So this is what the F table is created, but there's no data in it yet. Okay. And one more major information to be noted is when I go to this fact table detail runtime information, I see this table is by default partition. Now the question is very, very important. In the old schema, how many fact tables do we have? 2, F table and E table, right? So what is the purpose of the F table and E table? When you load the data normally, first it gets into the F table, and only when the data is compressed, the data is moved from F table to E table. Now the question is what you get the question this way. So in case of unoptimized cube, how many fact tables do I have? One, which is F table. Now when there's only one table, now the question is, do I still have the concept of compression in this cube? Can I still compress my data in my HANA optimized cubes? Got the question? In the older cube, we had F table and E table. We still had the concept of compression, which says when the data is loaded, it gets to the F table, and when the compression is done, it does move the data from F to E table. But in the new cube, which is HANA optimized info cube, it has got only one fact table only, which is F table. Now, does it support compression? That's my point. Forget about whether it is really required or not. That's a secondary question. My question is, with a single fact table in HANA optimized cube, will it still support the compression concept in it? That's my question. Any guess was? Yes or no? No, don't answer me that you don't need compression. Forget about whether it is required or not. My question is, will it support compression or not? That's with the single F table, will it support or not? Yeah, good. It supports compression. It supports compression. If it's still supporting compression, then how is it supporting this? Now look at this. What happens every time the fact table is created? By default, this fact table will have 4 partitions created with round robin. With round robin mechanism, there are 4 partitions created automatically. See, partition number 1, 2, 3, and 4. Every time, or for every fact table, in case of HANA optimized cube, it is by default partitioned based on the round robin with 4 partitions created in it. 1, 2, 3, and 4 always. Okay. Now we have to understand the importance of this 4 part. When I say round robin, it means these partitions will be used by the application which is using this table. Now, how are these 4 partitions used by your BW application here? See, whenever I load the data into the cube, all the uncompressed data before compression, all the uncompressed data will be in partition number 4. All the uncompressed data what I load into the cube, which is not yet been compressed, it will be into 4. Once I compress my cube, the data will move from partition number 4 to partition number 1. While it is moving, it basically drops the data packet dimension information, sets it to 0, and aggregates the records and puts the records into partition number 1. So partition 4 is considered to be the uncompressed, all the uncompressed data will be in partition number 4. Once it is compressed, the compressed data, it deletes the data packet dimension, sets it as 0, then based on the SID combination, it aggregates those records and puts them into partition number 1. Okay. Then what is the purpose of this partition number 2 and 3? Partition number 2 and 3 will be used only in case of non-cumulative cube. Like when you deal with non-cumulative inventory cube, only when you're dealing with non-cumulative inventory cube, not only inventory, but whenever you deal with non-cumulative cube, partition number 2 and 3 are used. Partition number 2 will store the initialized stock, which is compressed with marker. Partition number 3 will store all the compressed stock without marker. Initialized stock with marker will be in partition number 2. All the delta movements which are compressed without marker will be into partition number 3. So it always creates 4 partitions, but partition number 2 and 3 are used only in case of non-cumulative cubes. So partition number 4 is used to store all the uncompressed data, and compressed data will be stored into either 1 or 2 or 3 depending on the type of cube. If it is normal cube, all the compressed data will be into 1. If it is non-cumulative cube, all the compressed initialized stock will be into partition number 2. All the delta movements which are compressed without marker will be into partition number 3. Okay. So this is how the 4 partitions will be used here. That's how, because of this partitions internally, it still supports compression. Good. Next, someone has raised a question saying, when HANA is able to handle, even though irrespective of the whether my table is detailed or aggregated, HANA is able to handle the performance bus, right? HANA is able to handle the performance. Just try to understand me. We are telling that HANA is using columnar storage of data, a column store table. In case of column store table, data could be in any detailed format. HANA will handle the performance. That is what we are expecting. Yes or no, boss? So if that is the case, then what is the purpose of doing compression? Why should I do why should I compress the data? First of all, I made you understand with the help of these 4 partitions in the back end for the F table, it does support you the compression concept. So in HANA optimized cube, we can still have the flexibility of doing compression. Yes, fine. Okay, done. Next question is, do I really have to do compression in case of HANA optimized cube when it is a columnar storage? Because for this fact table, it is actually going to create me what? A column store table which can handle the data, which can handle the performance in any case of detailed format also. Yes or no, boss? So if that is the case, why should I do compression, boss? You got the question, you got this point, what I'm trying to discuss on. Yeah. So why do we still do compression in this HANA optimized cube? Is not for, we don't compress the cube to improve query performance here. Okay. We don't compress the cube to improve query performance here. In HANA optimized cube, I still do the compression to improve the performance of delta merge. Don't worry about size, because even though there's redundant data, in a columnar storage, it will store only once, right? We don't have to worry about size also. What I'm saying is, we will do compression in the HANA optimized cube to take care about the performance of delta merging. Do you understand that for every column store table, do we have to do delta merging? Do we have to do delta merging? Yes or no? Yes, we have to do delta merging. So to improve the performance of delta merging on this table, on this columnar storage table of the fact table, we do compression. Why? How? How does it improve? When I have 4 partitions, let's say partition number 1, 2, and 3, and 4, you know about delta merging, right? It will have delta table, it will have main table storage. Then when you do delta merging, all the data from delta will be written to the main, and then it is aggregated, right? Good. So what are the concept of delta merging? We understand. It will be performed for every partition bus. Means partition number 4 will have delta and main. Partition number 3 will have delta and main. Partition number 2 will have delta and main. Partition 1 will have delta and main. And when you do delta merging, it only performs the merging on the partition where there is a new data being inserted. Now, for example, let's say I have a cube. I have loaded 1 lakh records. So all these 1 lakh records will go into which partition? Partition number 4 or partition number 1 or 2 or 3 bus? Partition number 4. So partition number 4, delta table will have 4 records. Partition number 4, 4 delta table will have those 1 lakh records. When I do delta merging will be performed only on partition number 4. It takes those 1 lakh records from delta and writes it to main bus. Later point of time, again, let's say again I load some 2 lakh records to my cube again. So again the 2 lakh records will write it to delta storage of partition number 4. Again when you do merging, it is actually merging with 3 lakh records, 1 lakh records which are already in the main table, and 2 lakh records which are been coming in delta table. So with these 3 lakh records, it handles the merging bus. Okay. But look at the next case now. What I do, I load 1 lakh records to the queue. Now all the 1 lakh records are returned to delta table of partition number 4, and I do delta merging. So Okay, once I do merging to my main table in the partition number 4, then I compress my queue. So all these 1 lakh records will be written to which partition bus? Partition number 1. So now partition number 4 will have 0 records. Now again, when I load 2 lakh records now, the 2 lakh records will be written to which partition now? 4th partition. Now when I do delta merging, the new records has been written to which partition now? Only 4. So it does do merging only to 4th partition with only those 2 lakh records only, not 3 lakhs now. Again, if I compress, again these 2 lakh records are taken to partition number 1. Again, now partition number 4 is 0. Again, if you bring in, again when I do merging, it has to do merging only for delta records only, not for all the records. So in that case, to improve the performance of delta merging, we would still prefer to do compression on the queue, not for query performance or not for, because the query performance will be very minimal when you do compression in, because it's already column store table. But our intention of doing compression is about improving the performance of your delta merging bus. Okay. Now let's load some data into this queue and see. Since I want to load the same data multiple times, I'm going with let me finish this and I'll come to all the doubts. I'm okay with that. Okay, look at this now. In the DTP I have a checkbox here. Trigger database merge bus. If this is there, then what happens? Every time after the data load is done, the database it will trigger the delta merge bus. Okay. No data. Okay, 5 records are loaded. Now I should see those. If I go to my F table, open the definition, and I should see the number of 5 records in partition number 1. Sorry, partition number 4. If you look at this partition number 4, look at this record count. How many? Here bus. I see that 5 records here, right? Good. Now let me go and compress my queue. 623. Go to collapse. 623 and set use. Now there is no data now. 1 is 0. That is 5 is total record count. 1 is 0, right? Look at this here. So this request is compressed. Okay. Now if it is compressed, if I refresh, I should see these 5 records move to partition number 1. So now in partition 4 it is 0, and now I see these 5 records in partition number 1. So when you compress, the records are moved into partition number 1 bus. Okay. Now I have this inventory queue data leda. The data. I have this inventory queue. SIC. This is validated table is okay. Now I'm going F table. See now, in case of this inventory queue, it is using 1 and 2. 1 and 2. There's one which is initialized stock at this, and there's 4 records which is the movements portion. So it is using partition number 2 and 3 in case of a non-cumulative queue bus. Okay. Fine. That is what I want to touch on. Now tell me, now just let's go through the deck, then I'll come to your approach. So what is the benefit? So no, having understood about, okay, now one more point. Now tell me, in case of cube, we do merging because it's a column store table. Now what kind of merging will you prefer? Will you prefer smart merge or will you prefer auto merge first? Auto merge will be the one which will be triggered by the system automatically whenever based on some criteria is satisfied. Smart merge will be is the one what you initiate the merging by using some process type in the process chain. You initiate the merging. So do you prefer smart merge or auto merge? Smart merge. Good. Why? Because if I go with auto merge, I'll have this. It might affect my loading performance because now look at this. Say I'm loading 100 million records to my queue. Let's say after loading some 5 packets information or let's say 10 packets, it has satisfied the criteria for merging this. So system will straight away start merging. It does not care about data loading. So data loading will be kept on hold until that merging is done. So it will affect your merging process. It will affect your data loading. So if I would have stopped the auto merge on this table and I would initiate the smart merge on my queue whenever it is required. So it will not affect after completion of entire data load. I would trigger the merging with the smart merge. That is what we can do with the process chain in BW. If you go to process chains, you will have a process type called delta merging. Look at this. There's something trigger delta merge, which will be a smart merge. Okay. So having understood this, now tell me what could be the benefits of it. Now, with unoptimized queue, what is the benefits you will have now? Okay. When a simplified modeling, yeah, good. Because why? In case of normal queue previously, we had to do a lot of dimension analysis and understand which characteristic is assigned to what dimension. Yeah, we need to understand the relationships and then finalize, okay, these all will go into same dimension or these all will be into different dimension or line item dimensions, all this, right? But since my design is changed, there's no more dimension tables except data packet. So modeling is very simple. Straight away, you just group them because now the dimensions are like just like a folder. Just group them like any folder bus. But the limitations of 16 dimensions and 248 characteristics per dimension are still there, even though there is no dimension table physically existing in the backend bus. Then simplified remodeling. Good, excellent. Now tell me, in case of normal BW system with SQL Server DB2, in case of normal cube, now answer me this question. Once I have the cube created, yeah, and I've loaded a lot of data, now can I add a new characteristic info bit to the cube? Yes. Can we add a key figure into the cube? Yes. No need of remodeling. I'm just asking normally. Let's say I have a cube. It's created and I've also loaded a lot of data. Now I would just want to change the cube definition by adding a new characteristic. Can I do that? Yes. But now I have a different requirement. I have a cube which is already loaded with a lot of data. Now I would like to delete some key figure or delete some characteristic. Can I do that in normal cube? Huh? When there is data in the cube, can you delete a characteristic or can you delete a key figure? No, boss. No. But now with unoptimized cube, we can, whether it is data is available or not, I can straight away plug it out. No issues. Okay? For example, now I have this cube which I just created. I can easily remove my info. Say for example, so I want to remove these three. Yes. I can still remove, even though there is data in it, I can still remove those characteristic or remove key figure. That is what very simple remodeling of it. And it says faster loading bus. So in case of new cube, new schema, will it improve the performance of loading? Will it improve the performance of loading bus? Why? Because there is no more dimension tables except data packet dimensions. It will basically speed up the loading. No generating of dimension IDs now is not required. So that will speed up the loading, improve the loading performance to the queue. And one more point. Now I have dimension. Now what SAP says is, even though we have data packet dimension, it is just about generating one dimension ID per load, because every time you load once, it generates one request ID. For one request ID, I will have one dimension ID. So generating one dimension number for one request number does not really take time, does not affect your performance. Okay, so faster loading because there is no dimension ID generation except for the data pack, which does not really take much time. Okay, so these will be your benefits with HANA optimized queue. So we'll have all the data in fact table itself. Yes. Okay, now next question is, suppose now this is, so in case of, let's say there are two cases here. You have been given with a new BW on HANA system. Then what are the cube you create in this cube? By default it is HANA optimized cube. Let's say you've been given with a new system which is BW on HANA, and the cube what you create by default it will be an HANA optimized cube. But let's say if this is a different case. Let's say we had a BW older version which was running on SQL Server. Then you created a cube during that time, which was a normal cube, which was a normal standard cube. Then now you basically migrated your database from SQL Server to HANA database. After migration, the cube will be normal cube. You'll have to explicitly convert the cubes to in-memory cube, nothing but HANA optimized cubes. For that, we can either do with this program rs_convert cube to in-memory, or with this T code rs migrate HANA DB. If you go to this T code, you list out the cubes. You can list out multiple cubes, single value, range, exclude anything. Then you just say execute this or execute in the background bus. So this way you can basically in case suppose we already had a BW system set up with Oracle database and you created a lot of cubes. Now you have actually migrated the database from Oracle database to HANA. Now after migration, the cubes are as normal cubes only. We'll have to explicitly run this program, migrate HANA div, where you'll have to migrate those cubes to HANA optimized cubes. Then the schema gets converted. But when you're doing this, you don't have to drop data, nothing. Its system will handle that without dropping data. You can migrate those. And one more question they'll ask you. Say, I have a BW system running on SQL Server, and I've got BW system running on HANA database. Let's say both are connected. Let's say BW on Oracle is a development server. Let's say BW on HANA is a production server, and both are connected. When we transport the cube from BW Oracle to BW on HANA system, automatically the cube gets migrated. You don't have to migrate again. When you transport a cube from BW Oracle system to BW on HANA system, automatically the cube gets migrated. Okay. Okay. I can't migrate because mine is BW on HANA system. As soon as I create a cube, that will be by default a HANA optimized cube. So I cannot show you that. I'll come to with all your doubts. Wait. After the conversion, HANA optimized cube behaves just like a standard cube. Just before, there's no need to change any. See, when you're converting the cubes to normal, from normal cube to HANA optimized cube, you don't have to do any changes. No changes to DTP loading process, or not even to multi-plot, or not even to queries on the top. Nothing. Everything will be undisturbed. You just have to migrate the cubes. When you're migrating, even though you don't have to drop data, that is one, and no lower level objects or higher level objects will get disturbed. Okay, and one more thing, even during conversion, you can still be using the data for reporting, no issues. But data loading cannot be done. During the conversion process, data loading cannot be done, but it can be still be used for querying, no issues during conversion. And I just told you about 4 partition 1, 2, 3, and 4. That's okay. And this slide has got wrong. Partition 1 is compressed, partition 4 is uncompressed, and 2 and 3 is for non-cumulative cube. Okay. I think only one factor we still have to have the option to do compression. InfoCube compression is also executed as an unoptimized. And InfoCube compression, now the logic is not an ABAP program, it's a stored procedure. And compression is required to speed up the merging process. But this becomes only relevant for large or very large queues where the request greater than 0 is containing 10 to 50 million records. Inventory handling. So a new info cube BW HANA is automatically used for handling inventory also. HANA optimized cube can also handle inventory. And in case of HANA optimized cube, we don't really need the DB indexes or DB statistics. You don't have to really build the indexes on this HANA optimized cube or DB statistics to handle the query performance. It will be taken care of. Okay. And to know about handling inventory on HANA optimized cube, refer to this note 1548125. That's it. Now, what's your doubts? Explain inventory handling for HANA cube. Why do you want me to explain? There is a video. I think I'll just send across that video. Let's not waste time. See, it doesn't. It actually, in fact, it's pretty much same. For you, it is no difference. Internally, it does use something called record type and handle that. You don't have to worry. For you, it's all same. Initial stock movements is all same. Okay. In a SAP GUI screen, we are seeking colored arrow marks for back buttons. But in my GUI, I see normal arrow marks. Does that mean that's it? GUI might be old. Okay. Do we need to check the check mark for no? Yeah, you still have the checkbox. No marker update. Marker update. Yes. When I go to yes, I see it. You still have the checkbox. Yeah. Sorry. See, this checkbox will be handled by something called record type. Okay. If I have to show you, I have this right. See, there is something called record type. The dimension 1 which I have loaded for initial stock will have something called record type as 1. And the delta moments what is loading will be loaded with record type as 2. Okay. We will migrate the cube directly in production. Yes, we migrate the cube directly in production. Yes. We'll have all the data in fact table itself. Yes, all the data is stored in F table and SID tables. But even if we add a new characteristic to HANA cube, we need to delete and reload. Yeah, data loading is fine. But what I'm asked, that is fine to fill that. But my question was about just changing that to add or delete. With the data not possible. Fast data load as dimension table not there and reporting also fast. Yes. We'll include the steps in process. Yeah, we can include the steps for smart merging, delta merging in the process. Yes. As we move data from 4 to 1, will those 1 will be considered as new data for even if it is considered it will be performed only once, no? Because after merging we are moving it, right? Should support might be not required as it creates a column store. Yeah, I think this is all answered. Okay, so this is about HANA optimized cubes. We'll stop it here and tomorrow we'll get with next topic.
Hello.
Yeah.
So one basic kind of question, like for this HANA optimized info cube, so the info cube create that naming convention with Z or Y is not mandatory here. Like we can create with any name.
No. Even historically also, even normal build system also create with anything. We used to create with R, P, not a problem, but normally companies follow the standard of fixing Z or Y. Yeah?
Okay.
How many SI tables can be connected? You tell me. I'm saying the user defined dimensions should be 13, and I'm still saying each dimension table max 248. So 248 into max it will be 13, and plus you'll have data time characteristic SID tables also come there, units also come there. So that is max. Okay. Max I'll tell you. I will say 15 to 248 SID columns is max, I will say. Not even 13, because even time dimension is there, that also brings in SID columns. Unit dimension is there, that also brings in SID columns. So even if I assume the time and unit also brings in max 248, I'll say 13 plus the standard 2 into, I'll say 248. So how SID
Hello?
in the fact table? Normal as a column. Each SID will sit as a column in my SID table. How many SID? Yeah, please. Yeah.
Design of the cube, sir.
Design means?
Are 1:1, 1:m, and m:/m. Likewise, design of the cube it will be.
No more. No, you don't have to really worry about design. That's what I'm saying. Modeling is being made simplified. No more analysis. Straight away drop the relevant objects to relevant folder, because you just treat them as a folder. It's not physically existing in it. Yeah.
Okay.
Yeah.
Thank you.
Yeah. So, sir, during
Sir, I have a question.
During migration to HANA, we need to migrate the cube and development system and move it across the large scale. But either ways you can do, because even when you're transporting itself, the cube gets migrated. You don't have to migrate. What I'm saying is, if you're transporting a cube to BW or HANA system, cube itself gets migrated automatically. You don't have to migrate it again. During transportation itself, the cube gets migrated. But preferably we would migrate that in the production development first, and then make sure we migrate that into quality, and then we don't transport that objects again. No. We prefer to do migration production again separately. Yeah.
Okay, sir. Thank you. Okay.
Please send us a deck too. Okay. How many? This is answered. How many columns in fact table? Max, I was referring as 1,000 columns. Yeah. There's nothing like, but actually they say max is 1,000 columns in a table generally. Yeah. Okay, boss. Thank you.